Hi everyone, in this video, I'm going to take you from zero to hero in Docker with React and Node.js and plus Docker Compose in a one single simple easy video for you actually guys to learn. So in this video, which basically I'm going to cover up is actually Docker of what is Docker and how Docker works and all that sort of stuff. And plus we're going to integrate all of those together throughout like a Docker file. So we're going to take a real world application with a client running on React and different technologies, and of course with a Node.js server running Express and with actually a database connected, which is PostgreSQL. All of those are going to be like taken together as a stack. I'm going to Dockerize the whole software, like the whole stack, using Docker. And of course, we're going to use the advantage and like the CLI of Docker Compose to put all of these services together and run them with a single line of code. And of course, we're going to have all this journey from start to finish into like doing this way on this particular video. So if we start off like in this one, like what Docker is, like for a simple beginner friendly startup on how or what is Docker is in this particular sense. Clearly, this is actually the website of Docker. If you're not familiar with it, if you're like complete beginner to Docker and you don't know exactly what Docker is. Now, Docker is a set of platform as a service products. So if you're familiar with PaaS, or like products or platform as a service, So this is what Docker is. It just like provides you with this kind of like abstraction, like OS or operating system abstraction. And it's kind of like an alternative, I would say a really good alternative to virtualization. If you're familiar with that, we're running different operating systems isolated from each other's on top of hosts or something like this, where like VirtualBox or VMware runs. So this is where Docker comes in handy. It does kind of like do virtualization, but it do it in a special way. It's kind of different from the old ways. It does like an operating system kind of like virtualization, which makes it super performant, super safe, and processes are completely isolated throughout the whole kind of operating system. And it allows you to run tons and tons of containers at the same time without losing your sanity or without losing much of RAM and resources of your computer. So that's basically what Docker is. And Docker, of course, allows you to run basically applications independent from each other's, like completely isolated from each other's, without the need actually to go into virtualization, without the need to write a really complex code. All you're gonna need to go and run is actually a couple of like lines of code, and you can turn your static, regular, standard application into a Docker compatible image application, or like a compatible Docker container running isolated from other containers, running isolated from your own host, running all in just like a completely bare Linux kind of like operating system or Linux kind of like container having all that info. So that's basically what Docker is, and that's basically what Docker does in that particular sense. And that's why you've seen Docker have been shining throughout the whole years. And it's basically, if you'd like been seeing this and didn't have the time to actually go into Docker, well, this video is actually for you to jump into Docker and know exactly how to go ahead and start with Docker and how to work with Docker and learn Docker from start to finish. So if you see, this is basically the Docker's, or basically what Docker is, and Docker's website, like how you do Docker and why Docker is very important. Right now there's this Docker Cone live going on. Of course you can go ahead and watch it, whatever. I'm gonna catch up on this, like on the kind of like recaps or something. But whatever. So that's basically just like a simple introduction to Docker and how you do Docker basically. Now, the other question in here before starting the video is actually for you guys to know exactly, like whether you start with Docker or not. So like, why should you choose Docker versus other kind of like technologies like VMware or virtualization in the first place? Well, Docker gives you the opportunity to run or Dockerize your application in a really, really simple way at the lowest cost. It's basically available everywhere. It's everywhere. Like servers running Ubuntu, CentOS, Fedora, any kind of service, and like AWS, Google Cloud platforms, any kind of like platform nowadays has Docker integrated with a huge capability and huge components integrated throughout the Docker's ecosystem. Now for Dockers in this side, you can actually take your own application and you can turn it into a Docker compatible. Then you can have this application actually built into a static image. And this static image, what it does is just like a static with the whole instructions, with the whole source code and everything you need, then you can take this image, actually distribute it with your team, with your rest of the developers over the rest of the world, as a lot of people are doing, open source stuff. And those images can be pulled down into like local machine, and they can like run this like images or run these containers, which of course images turns into containers like never before. And those containers, what they can do is pretty much anything, like running an isolated, simple and minimal and really small kind of like operating system inside of your operating system that does it really well. So imagine you can go in and run like a MySQL server without going to do like the fuzzy and the ugliness of installing MySQL on your server like Ubuntu or something like this. Or you're going to go and do like go with Docker, you pull the image, you do Docker run MySQL ports 3306 or something, and hallelujah, you got MySQL running into Docker and everything you needed. All you have got to do is actually connect to MySQL and get up and running with your servers. So that's basically what Docker is, if it like summarize it of whether you need Docker or not, and how to do that. And of course, in a DevOps perspective, Docker makes our lives much, much easier as developers. We don't have to worry much about how deployment is done and how servers configuration is done and all that sort of stuff. All you need to care about is actually Dockerizing your application, adding the proper configuration file for Dockers, and boom, just build the image and deploy it, and you're ready to go. That's it. That's how all it does with Docker, and that's all you need. So yeah, so that's just like a simple kind of abstracted description about Docker and how it works with that. So we're going to be like going and starting with installing Docker and get up and running. And of course, we're going to get all the rest of the stuff about like Dockers and what Docker containers are and Docker images and managing all of those throughout the actual CLI. And eventually, of course, said before, we're going to Dockerize the full application. We're going to use Docker Compose. And we're going to make sure that we do this in a really funny and awesome way, as we always do it on Coder1's channel. So if you're new here, make sure to go and subscribe and push that like button. And without further ado, guys, hope you guys enjoyed it, and let's go ahead and get started. So let's go ahead and get started. And first things first, what we need to do is actually install the Docker engine. So if you're familiar with the Docker engine and everything, how it works, basically underneath, well, you have got to install the Docker engine, which is basically the whole engine, or what's called the Docker daemon, that's going to empower how Dockerization is going to work, or containers are going to run on the host machine. Mainly Docker best works for the Linux operating systems. So right here I'm running Linux Ubuntu, latest version of Ubuntu, and it's pretty much going to run as smooth as possible. For other kind of distributions, Docker works really, really well. But what I mean by this is like Docker is really supported on Linux, and more specifically on just like Linux operating systems. But for other places like Mac OS X and Windows, yes, it does work really well. And installing there is just like kind of straightforward and pretty simple to install, because there's just like this kind of like binaries and executables that you click, you run, you click next, and there you go. You got the installation done for you and everything. So this is pretty much what I'm going to try to say right here. And we can just go and access the Docker or the download and install section. As clearly see, there's a ready-made Docker desktop for Mac and a Docker desktop for Windows. But for Linux, it's quite completely different. And if you're on Windows or Mac, just click on one of these in here. You're going to take you, download the executable, you click it, you install it. That's simple. Now for Linux, it's quite different, and it's quite kind of like a little bit kind of hectic. You have to go ahead through it and read more like what architecture you're on and a different, the servers in here. There's actually a desktop security for both of these, but this one is more specifically designed for servers and how they work. So as I said before, I'm running Ubuntu and my architecture is like x86. So yeah, we don't have to worry about ARM or something like that if running any kind of like CPUs. So if you choose Ubuntu in here, it's going to take you to another page, and this is where you need to like install the new Docker. If you've got like an old Docker version, you install it first, but the installation method should be pretty simple. And this is the installation method I'm going to use which is basically just following the installation throughout the repository, which is officially how it should be done. So you just like you update and you install, then you just like, download the script and run that and just like install the Docker engine, and that's it. So that's pretty much all you need to do for that particular case. So yeah, we can go ahead and just like walk you through on how you do this on like Linux in here. It should be pretty simple, as said before. Nothing really too complicated or something. So all I'm going to be doing is just like copy pasting script, and that's it. So just like following this tutorial should just be copy pasting scripts to install the Docker engine on Linux. And yes, I'm saying it one more time. This is going to be on Linux. For Mac or Windows, just download the executable, execute it, and you're ready to go. So you have got nothing to do anything other than that. Okay, so pretty good. Now let's go ahead and jump into how installation. So first things first, what I'm going to be doing, I'm going to do sudo apt update, which is going to update everything for us. I'm going to install my sudo password and everything. Seriously, it's going to do the full update and everything. So it's going to take a couple of time. And to be honest, I've already installed Docker, so I don't want to just like spend thousands of times waiting for Docker to install, because this is not a tutorial about just installing Docker. There's a bunch of stuff we need to go through the tutorial. Okay, so after updating here, we need to go ahead and add a couple of repositories. So this command in here, which should go ahead and add do apt install, and it's going to install all of these, like the apt transport HTTP, CURL, or curl, CS certificates, plenty of stuff that Docker is going to use underneath behind the scenes. So make sure to install this properly in order to work. Now, the second thing we need to add Docker to our like active repositories and add the GPG link, which is just like for making sure that we are pretty much downloading and executing authenticated Docker stuff. So nothing really messed up or counterpart, something like that parts. So just go ahead and just run this one, and this one is going to just like verify and make sure that okay, you got the right version and you got the right GPG and you're ready to go. Next thing here is actually depending on the architecture. So it just gives you like what type of scripts you're going to be running, and of course it depends on what kind of like operating system or distribution you're running. So yeah, it goes from like if you're on Ubuntu or CentOS or Debian or something like this. And yeah, so you make sure you choose your own kind of like distribution in here, and this is basically just gonna go ahead and add Docker to the sources list and just download to you the Docker stable release for Ubuntu. So click that, enter, and that should be done. And last but not least, what we need to do is actually run another sudo update, which is gonna just like update from the newly added repository that we've just added right now. So make sure to run the update. And afterward, what you need to do is, last but not least, is actually to install the actual Docker engine. You just like do sudo update install Docker C, Docker C, CLI, and container.io. So those apt-gets or those kind of like packages is going to do the job for us perfectly, and this is going to install Docker into our Linux operating system, and more specifically into Ubuntu. All right, pretty great. So that should be making it all work together in a really, really good way, and we should all be actually working really, really well in that particular sense. So this should be all the dependencies and all the steps that you need to follow. Yeah, it might kind of like differs from one operating system or from one distribution to another. So for CentOS or Debian or Fedora, I don't know, it will be quite different and a little bit kind of different from that on Ubuntu. But yeah, they're still all the same, just copy pasting scripts, just putting them there, and make sure you copy the same order. You don't get like really messed up into that, and no weird errors along the way. And yeah, you get that's actually working absolutely fine. All right, pretty great. Now to make sure that Docker is actually installed on your machine, now you need to actually use the Docker CLI to run hello world, more like a simple hello world container, just to make sure that it's actually installed. So to do so, go ahead and do Docker, and you do run hello-word and click enter, and this is just wait. And if you get this message which says, oh, hello from Docker, and this message shows you that your installation appears to be working correctly, well, yes, this message indeed tells you that you've got Docker installed, Docker engine, and Docker CLI pointing perfectly with path set it up correctly. So you get everything as you want it to be. And if you do docker dash help, of course you can get the full help message in here, and with different commands that you can use and all that sort of stuff. Yo, hallelujah, pretty good. We got Docker installed and everything to be running the perfect way as we want it to be. All right, pretty sweet. Now Docker is actually installed. Everything should be working fine as we want it to be. Alright, now we run our first containers. Clearly see, I'm pretty sure like you're still kind of like not familiar with Docker containers and how they run. Yes, we're still going to go into details about this and how they work. Alright, now the most basic Docker commands, of course, how you can learn them is actually throughout the CLI. So the Docker CLI this is how you access it. And as said before, the Docker CLI is already added into your path. And what I mean by this is a path is pretty much like an environment variable that tells Linux, more specifically, if it's available on Windows and Mac as well, but I'm talking on Linux this perspective. So path is just like tells it where to look for binaries to pretty much execute them. And Docker in here, of course, is going to be putting on our like local user binary or something. And yeah, it knows exactly how to run that. So just like by typing Docker, it's going to go in and search for the binaries. It's going to find, a binary matching this name we put in here, Docker, and it's just going to execute it for us. That simple. So this is why the CLI here is actually working for us this way. Now, the second thing you need to notice is actually the CLI is pretty much the client. Now, behind the scenes, Docker, so as soon as you install Docker, there's this like Docker daemon or Docker D. So this Docker daemon, what it does is pretty much always running in the background. So as soon as you install it on your machine, it's going to be always up and running. So whether you restart your machine, you log off and you log back in, whatever, it always is going to start the Docker engine behind the scene. Is always going to be in the background running somewhere. And this Docker daemon is pretty much like the server of Docker that is going to control everything from containers, installing images, controlling how virtualization works, how to handle OS operating system, kind of like level isolation and all that sort of stuff that Docker needs to be taken care of really well. So yeah, so this is the Docker client, and for the Docker client in that particular part, what it does, so as soon as you give it a command, this command is going to be sent to the Docker daemon, and the Docker daemon is going to like, do some handling, some low level stuff on the Linux kind of like operating system, really low level, and it gets back with a response to the Docker client. Then the Docker client shows it up in the CLI in here or the terminal, and it shows a really friendly message for us. So this is basically the simplest architecture of how Docker actually works and operates behind the scenes. So just for you guys to get a grasp of how Docker actually works and to be able to know exactly how Docker is manipulating all of its commands. All right. So yeah, as I said before, this is Docker CLI, and this is what you're going to be using for pretty much accessing everything, for doing any kind of command, for running containers, stopping them, and everything. And the Docker command in here, if you do help, you're going to have a bunch of commands listed in here. And what I like personally about this CLI, the Docker CLI, is actually it gives you a pretty well descriptive messages of commands and what they do. For example, for the attach, it does like attach local standard input into an output and an error stream to the running container. So you just like by looking into this command and read through this like simple one-line description, you know exactly what this is doing. And yeah, you just like, oh, this is doing this. All right, that's good. I'm going to use this command. So without just going and looking into Google, Stack Overflow, or even the docs, which kind of like awful to do all the time, especially for us as developers. All right, so this is pretty much the whole commands. Now, there's a bunch of commands that you're going to be using throughout. You're going to be using pretty much more than the others, and the most standard and common commands that you're going to be needed. For example, this is Docker PS, and this one stands for process status, which is going to give you like the currently running containers that are currently running on the Docker engine. Right now, there's no Docker containers running. They're all stopped. And if you do like Docker-A, which shows you all the containers, so you see there's a bunch of them. And this A flag in here, what it does, just like shows you all the type of status of containers, whether it's stopped or whether it started, it shows you that. And as you see, all of these containers are stopped. If you see this like hello word, that we started it just like 5 minutes ago, it stopped right now, it exited just like after 0 seconds and 5 minutes ago. And it gives you like the container ID, and yeah, it gives you like this basic information. I'm just gonna, give you a little bit more space in here to see what exactly happening behind the scenes. So yes, clearly this is pretty much, it gives you like some kind of descriptive of what is happening behind the scenes and stuff like that. As clearly it looks pretty great, and it gives you the whole repositories, or pretty much the containers that are already started, because I use this A flag. Okay, so this is just basically for the PS or process that's used, because we don't have any kind of Docker container currently running or something from that sort. Now, the other cool command and that you're going to be using a lot is pretty much to check your images. And if you do like Docker images with an S at the end, you click it, and it's going to give you the full list of images available on your system. Of course, so you can have images downloaded and pulled down into your system at any time, or built from, you know, your own kind of applications all the time. Or what you can have is pretty much like just pulling images from the kind of like repositories. And the most common repository to pull images from is actually the Docker registry or the Docker Hub, which has mostly the free or open source kind of like images, or even private images. You can host them there or whatever. So this is pretty much the full list of images you've got on your own local machines. And what I mean by images is pretty much like a build kind of like container, which is just an image, and it's not like a running container or something like that. It's just like image sits down there, and it has all the instructions abstracted. So Docker later on, if you try to run this image, what it does, it takes this like kind of like image, just like this kind of like a small image, and it puts it inside of like a container, where the container is pretty much more like a small manipulated Linux container. And you can think of it like a separate operating system, like a separate machine on itself. So if you're familiar with VMware or VirtualBox or virtualization in general, so this is what it does. It just gives you like the full, allows you pretty much to run multiple operating systems on a single operating system. So this is kind of like what Docker does, but it's not doing virtualization in low level or like for type 1 and type 2 virtualizations anyway. But what it's doing is doing like OS level virtualization, which is kind of really speedy, really quick, and really performant. That's why Docker is really preferred in this field, and of having containers and running applications. It's just like a couple of seconds, just like less than a couple of seconds. That allows them to run these images. So this is basically what it does, and this is why we have images in here. So if you've got, for example, like a source code, which is like your application. So first what you need is pretty much go ahead and create like some configuration file to tell Docker how it's going to build this image. Now, after creating the configuration file, you're going to tell, oh, I got this configuration file. Now, Docker, go ahead and pick this config file and build me this image, which is my own personal application image. And this image has all the source code, all the commands, everything that you need to run the actual application. Now, after that, you can take this image, you can distribute it, you can put it on the Docker Hub, you can even have your own registry hosted on your server or other kind of like third-party servers. And afterward, you got this image. You can have this image distributed throughout the whole team, like with all the third-party teams or whatever. Now, this image can be pulled down by anybody, and as soon as they pull it down, they can just like do Docker run this image, which is going to run the image inside of a container, and this container is going to be a live container. That's going to be like a live small operating system running Linux and running this specific image and this specific image only. Nothing more, nothing less, just this image running, and it has all the data, all the info, all the commands, and all the source code needed to run this image specifically as you configure it to be. So this is basically what images are, and this is how they basically work. As clear as in here, as I said before, we got this all of images. Clearly, they are ridiculously when it comes to like space, and this is mainly because I'm using more like Node.js, and Node.js images is kind of huge. So if you take a look on this is Node image, which is 904 megabytes, almost a gig. And if you add on top of it your own kind of like source code or your own application running on top of Node, yes, this is going to be added up, and that's why you see this huge size in here for more like 1 gigs and up, even here like 4 gigs and all that sort of stuff. So yeah, I mean, this way of doing Docker is really well, and images plays a really major role. Now, what you can do as well, there's an alias command for this. So you can do image ls or images. That doesn't really matter. And you can, of course, there's another command called pull, and this command allows you to pull a specific image. For example, let's go ahead and pull the BusyBox image. And so yeah, sorry, I haven't done it right. So we can do like pull BusyBox, and there is actually a BusyBox. Okay, I can't type properly. This BusyBox image is actually setting up on a Docker registry, and what this BusyBox just does, it just emulates or pretty much like simulates a small kind of like Unix operating system that just pretty much provides you with Unix commands like. So yeah, just a small container there to do it. And as clear as I already pulled that out, and it already like pulling the latest from library, BusyBox, and images up to date. So I already got that on my host machine. So it gives you all the information you need, which is pretty great. And if you do something like Docker images, and you're gonna find pretty much BusyBox there. So if you take a look, where is that? So there you go. We got BusyBox right over there. And you can now use this image, more particularly this BusyBox image, and run it as a container. Now it's just like a sitting, frozen kind of image, just like sitting there doing nothing. Now you need to run this container or pretty much run this image in order for it to convert it to a container and be live and work pretty much. So to do so, you can use the run command, which is of course another very important command. And this command, what it does, it just like runs you a particular image, and it just like runs it inside of a container, and you give it like a bunch of like flags on how to control that. For example, if you want to control ports or to control volumes or all that sort of stuff. We're going to be seeing this later on as we go a little bit advanced into Dockerizing a full application. But for now, I'm just going to use a BusyBox command. Just going to run it ber BusyBox. Okay, so I'm going to do run BusyBox, and here provided with the image name. More specifically, if you want like use a specific tag, for example, you got BusyBox version 2.3 or something, or you want to use the latest version of BusyBox, you can do it this way. Mainly, if you just like ignore that, it's going to use the latest version, or if you provide that, that will be good as well. But yeah, so that would be good. So just do a Docker run BusyBox, and this is going to take us seriously. It's very, very fast. Seriously, like how responsive it is to run it. It takes like 2, 3, 5 seconds or something just to run the Docker container. So what it's doing in here behind the scenes, it's running or starting the Docker container. It's pretty much like handling some kind of stuff inside of the container. Then it's stopping the container. So this is all of it taking like 5 seconds. Imagine if you did this particular step on an actual virtual machine or like in virtualization. How many kind of seconds this is going to take? It's going to take a ridiculous amount of time, like at least I would say 5 minutes or something, which is kind of enormous when it comes to development and deployment and all this sort of stuff. So the BusyBox in here, what it does nothing, right? This is just a standalone, basic kind of image that's going to just like run, as I said before. You provide it with particular command, a Unix command is going to run it. So for example, what we can have, for example, I'm going to say, oh, you go ahead and, I don't like this latest, let's go ahead and get rid of it. So I'm going to say, oh, run me this ls. And if you take a look on it, what it's going to print, it's going to print this ls. And indeed, this is not my machine. This is actually, it's going to do a list. It's going to do ls command inside of the BusyBox container it's going to create, which is going to print me this. And inside of the BusyBox, indeed, is going to be the Linux distribution or the Linux Docker container running there with the BusyBox image in there running. And this is what is printing me. So indeed, this is actually what's happening. We can, for example, do ls, and I want to go ahead and see home if it does have anything. And luckily, I don't think home does have anything. So yeah, you can see that there's nothing. For example, for bin, we can just take a look what binaries is available. And there is just like basic binaries that is provided with bare minimum Linux distributions. And this is like what binaries it has in there. It basically is based on Debian or Debian, sorry. And yeah, you can use like commands like apt-get and apt-get update to install different packages in that particular sense. Alright, so yeah, that's pretty good on how to run in basic stuff in this and how to run kind of like basic commands or basic containers on Docker and using it this way. So that should be pretty simple. There's actually another thing we want to like go ahead and run, for example. So let's say I want to run the Postgres kind of SQL or Postgres DB using Docker. So in this particular sense, I'm going to have this image in here for my Docker hub. So let me just point you to this. So curiously, this is the Docker hub. So it's called hub.docker.com. And this is where most of the Docker images already created and already pushed up images actually live. So this is the Docker hub, and those are actually like some official open source images that you can find, of course, for Postgres and stuff like that. And you can all you need to do is just go ahead and do like Docker pull Postgres, and you're gonna get this particular version, and you're gonna have like particular stuff like description, and inside of description you're gonna find like some versioning, quick reference, what it does, how to run it, basically like what commands you need to take a look on, how to use it, for example, with Docker Compose, and plenty of stuff like information on how to run this, and environment variables and configuration, all that sort of stuff. So it has everything you need to pretty much run pretty much this image and like put it out and start working with it locally. And why not use Docker files or extend this image and use it to pretty much work with your application, or use it throughout Docker Compose alongside other services or something like that. So that is all available throughout the Docker hub. So let's go ahead and see. I'm going to run this Docker Postgres SQL throughout the Docker command and run it and see what is actually going to happen. So let's say I want to just like start up this Postgres SQL server locally in here. So for this, I want to go ahead and do Docker run. Or what you want to first do is actually go ahead and do Docker pull Postgres, and you can specify a version, for example 11.5 or something. And for some reason I'm choosing 11.5 in this particular video because latest versions like 12 and 13 are not basically working with Node.js connection and with Node.js project. So there's some really weird error that's happening behind the scenes. That's why I'm falling back to this version, which seems safer and it seems working perfectly. So just like a quick notice about why I'm using this. So just Docker pull, and it's going to pull the latest available version on this hub. Or what you can do is actually go ahead and like run Docker run directly, and Docker is going to be smart enough, if it doesn't find the actual image in your own machine, it's going to try to pull it first, then to run the Postgres. So make sure to do it anyway, the way you like it, of course, to make sure to run it this way. So if you take a look on the documentation real quick in here, I'm going to find like this real simple command that allows us to tell on how to run Docker more particularly. So let's go and do like Docker run, for example, or let's see. So yeah, this is pretty much command, sorry. And we're gonna run. So I'm gonna do, let me just gonna copy the command. All right. I don't want to just like keep seeing the command and just like explaining. I want to copy it, explain it, and that will be all good. All right. So you do Docker run, and this is the name of the container that I'm going to be like giving it, and the name of like the Docker container, the running Docker container. So let's say I'm just going to name this Postgres. Okay. Now for the Postgres password, this is going to be the root or the Postgres user's password that's going to be used. For example, I'm going to use something like pass123. And if you're wondering what is this E flag, this one stands for environment. So E, we're going to set this Postgres password variable as an environment variable inside of like the running container, which is going to be the Postgres running container. So this one is going to be like simply an environment variable inside of that particular container. And the D1 in here is going to be like as a daemon. And last but not least, we're going to provide what the image name we're going to be using. You can use like version, for example, 11.5 in my case, or you can do like latest or something like this, and it's going to pull it out. So I want to use 11.5 of this particular version, click enter, and this should run as Postgres SQL. Curiously, it returns this SH8 or this particular unique ID about this container. And if you take a look on Docker PS or process status in here, you're going to find all the info about like Postgres and the currently running the Docker container. So like unique ID, which is just like a portion of this, the image like I'm using, the version, everything, the command that is already run, when it's created, the status. And there's actually a port which is 5432, and this is actually the exposed part. or the port that Postgres is used to run on. And as you see, this port currently only running inside of the container. It's not exposed to us on the host. So if we try to access this port from the host, from our machine in here, we can't access it because it's not exposed to us to the host from Docker. So to expose this, all we have to do is go ahead and like tell it to expose that particular port. So let me just go ahead and like stop this container. So I'm going to do stop. And to stop a container, basically, this is another really helpful command you're going to be using, is for like getting rid of or removing containers, you've got to first stop the container, then remove the container. So you can either provide the name in here for the particular container or the ID. So yeah, whatever is going to do the job perfectly just to stop it. I would use the unique ID, that would be safer. And just Docker stop, error, there's no, let me just see. All right, the same something. Let's gonna try Postgres. Try to the name and see what that does for us. There you go. It stops. For some reason, maybe you copied this wrong or something, or with a space. Yeah, I think that's a wrong one. That's what it seems. I don't know why. Okay. So yeah, whatever. So we got this particular Docker kind of like stopped. And if we take a look again on the process status with the A now, as you can see, the Docker container still exists. It only stopped it, but it didn't actually remove it. And what we want is actually completely remove the container to start a particular new one container. So to stop or pretty much completely remove the container from the hibernated or from the stopped containers list, you're going to use the RM, which is pretty similar to the Linux or Unix kind of like command to remove files and all sort of stuff, or to move resources. So RM in here, you give it like the ID or the name. Or what I would like to use a lot is actually to remove all the containers that are already listed and all the containers that already run before. Because actually you can use the RM, and there is this like really handy script which you can actually embed another shell script inside of it, which is you can do like another docker ps -a-q, and this one's going to bring you all the list, and this one's going to bring you all the list, but it's going to just like do it into the std in, not print it out, but into the std in. So the rm command in here can use those kind of like values. And what this one is going to do is pretty much going to remove all the hibernated, all the stopped containers for us. So if we click enter, you see we get a bunch of IDs printed for us. And what does that mean? It just basically means that we got the command particularly executed for all of these containers, which means like all of these container IDs are deleted. So as soon as a container is deleted, just gonna spit out and display the ID of that particular container that say, oh, hi, this is the deleted containers ID, and that's it, just like for your acknowledgements. All right, so yeah, pretty good. We got all of that. So we're doing again docker ps-a, no images, nada. Even the like stopped hibernate images, all of them are gone. And from time to time, of course, as developers, me and you, from time to time, we have to clear this sticky cache that is pretty bad. It's gonna just like eat up memory, and you don't even realize it. And it's gonna eat up a lot of memory. Believe me, I tried this a couple of times, and even ended up with like 200 gigs of Docker's images and Docker's containers and cache and all that sort of stuff. So from time to time, make sure to check out the Docker cache and make sure to clean that up before going to bed every night or something like this. All right, pretty good. So coming back into our main stuff in here is actually running the Docker command. And let me just use this. Okay, I want to get back into the Postgres. Now, the Postgres I said before is going to run this, but what you want is actually to expose the ports. Like Postgres in here mainly runs on 5432 ports, which is going to run internally inside of the Docker container itself. But what we want to expose this to the host, which is our current machine in here, from the Docker's container, in order to be able to access and connect to the database. So to do so, we can use the p command, which is just like stands in for ports. Now to expose this, first we provided like what is the host ports we want to bind this to. So I want to use the same port, like 542, and what is the containers port we want to bind to. So the containers port, of course, like what port is being opened inside of the container by Postgres. And obviously this is actually 5432. But for the first part in here, like what you want to bind to, you can choose whatever. You can choose 8000 or something, and this is going to bind 5432 to 8000 ports on your own host machine. All right. I'm going to just like make this a little bit more accurate for you guys. So I'm going to make this like 8000. All right. Just to make it a little bit more simpler, and go ahead and run this. So this should run the Docker container for us. We do Docker PS. Now we're going to see another piece of information, which is pretty important. We're going to see the ports, and the ports right now is clearly see this 8000, which is on 0000, which just basically represents our local host with an 8000 port is bound inside of the TCP container or inside of the Docker's container to 5432 TCP ports on the Postgres container. Now we can use these ports to connect to the actual Postgres container, and that should be all good. Now we can go and use like the psql pretty much command line, which is like a client that allows us to connect to Postgres kind of like databases. And we can, for example, say, oh, we wanted this host on the local host, and we can say like the user is Postgres, which is by default created by the Docker container in here, by the Docker or by the Postgres image. And you click enter. Like it doesn't know the port, of course. By default, it tries to connect to this port, but we changed the port, so we're using a different port. So make sure to provide the port here, like for example, say P8000, and it asks for the password. We already provided password like as pass123. So pass123, and hallelujah, we got access to our server that is running inside of Docker. So even though you're not going to be using Docker for development or something, you can even have images and Docker containers running your own kind of like databases, servers, and like MySQL, Postgres from time to time. And this should be pretty simple. It should be like really easy to set up, really easy to destroy, and really easy to download without just going through the mess of installing inside of Ubuntu, configuring it, and going to the config file, and version mismatching, and all sort of awful stuff that I hate about this. But Docker makes it super sweet to handle and super easy to work with. Sweet. Now, yeah, you can do whatever throughout the CLI, like list whatever kind of databases are available there, whatever you can do with Postgres, of course. So I want to quit and I want to go into something completely different. Now, the Docker container in here is already running, which I don't need anymore, because what I need now is pretty much to go ahead into the Docker file. So Docker stop, and you can of course use the same command I used before to stop it all, but I'm just going to use the Postgres. I'm going to use its name to stop it, and make sure to remove it as well. I don't want to use any like jargon or something, and that is removed as well. Pretty sweet. We got Docker, everything made up in a really awesome way. Now, enough Docker basic stuff. Now let's go and jump into creating the most important one, which is the Docker file and Dockerizing a real world application. So the real world application here we're going to be using is actually called the Jira clone. So the Jira clone, familiar with Jira, it's like, the task management here, the Scrum and different techniques which are used by developers and teams. And so yeah, this is actually a really well made up clone that is made up between two parts. The API, which is created throughout Node.js with TypeORM and Postgres database running. And the client in here is actually using like React and everything to run that. And of course, some Node.js to run this. So it's basically a full Node.js kind of like full stack Node.js application with React running, Postgres, and many stuff like Express for Export API and everything. So what we're going to be doing with this application more particularly, I'm going to clone it. I'm going to take this application for granted, and I'm going to just like Dockerize this application from start to finish. And last but not least, we're going to also add Docker Compose to create this kind of like services, kind of like architecture of how you can pretty much integrate everything into a single Docker file. And with a single command, we can have all our servers with all stack running up and running without any issues. So for example, you can have Postgres server running up alongside the API server, alongside the actual React client server running, all with a single command, with the all configuration and everything throughout Docker. So I'm going to be using this. If you want to use this kind of like demo, or when you're going to use this kind of projects for demoing and make sure it works perfectly, you can go ahead and like clone it up using this link and just click it, clone it up whatever you want, and you can have it. So I already got that. I already opened this through my VS Code in here, and I got some jargon in here. I don't know why. So I'm going to completely get rid of this as soon as like I need it. So there's actually a bunch of stuff in here. So for example, the client, which is in its own kind of application, and there's the API, which is its own application as well. And there's this kind of like node modules is shared between both, which doesn't really make a lot of sense, but there's this package.json that allows you to, for example, start production for both client and API, or install dependencies of all that sort of stuff. But since we are going to be Dockerizing the whole stack in here, we're not going to be needing that much of this package.json anyway. We're going to be needing or using the internal package.json for both of these, the client and the API, to make sure it works perfectly. Alright, pretty sweet. Now, first things first, what we're going to be doing is actually Dockerizing each part alone. So this one is going to be its own server, the client is going to be its own server, and I'm going to be Dockerizing each one in here and actually connect them throughout RESTful APIs, since they are already like connecting and talking throughout RESTful APIs. So we're going to make sure to run them on separate ports and just like define, oh, this is the port, this is one running, and vice versa. That's basically what we're going to be doing throughout this. So to start, actually for Docker to pretty much work and be able to take kind of like the projects and make it a Docker compatible, or create an image from that project, basically, it has to have a Docker file. So you're going to go ahead and do like a Docker file, and basically for international and many people use this naming convention is actually to start with a D as a capital and just like, name it this way with no extensions, nada. Just like put it this way, and it's available enough. And actually I'm using some extensions from VS Code to have this Docker recognized and everything, to have the syntax really made up with some IntelliSense. So you can go ahead and grab this from VS Code extension store or marketplace, if I'm spelling that right. Okay, so this is the Docker file I'm going to be using, and basically for the Docker file I'm going to be using, is pretty much like what's gonna happen is pretty much going to take this Docker file or this project in here and tell Docker how we're going to use this, or how the build process is going to be going throughout this to build this actual project into an image. And what I mean by this is actually this final project, the whole files in here, the whole configuration, the whole node module script and everything is going to be taken out, is going to be put inside of an image, it's going to be bundled inside of like this really compressed and bundled kind of like Docker image. Now, whenever we need this image, whenever we need to run the application, all we need is basically just like this static image, like single file piece image, and we grab this image, we use a Docker command run, and we run the image, and the image runs as expected to be every single time, with no unexpected changes or any kind of like odd behaviors that we didn't include. So that should be just that straightforward about creating images. And we have to use actually this Docker file to tell it how to Dockerize or how to build the image for this particular project. Alright, pretty sweet. Now, for every single Docker file, what you need to start with is actually the from. Now, the from in here tells it like what base image we're going to extend to be able to build this image, because obviously you're going to be needing some base image to run this. So for example, if you got like a PHP kind of projects which presents or runs on top of PHP, or for example on top of Laravel, so you're going to need the basic or the PHP kind of image, the Docker image, of course. You're going to extend this to be able to like provide the core, provide the actual PHP kind of like binaries and interpreter and the whole language kind of tool set to be able to be used to bundle that into the image and used actually internally inside of the image or the container. So this is what's going to happen as well for us. So we're going to extend the Node.js kind of like or pretty much image, which we already got from Docker, or which gonna already be like pulled out automatically if you don't have it locally pulled out. on your containers or on your machine. Docker is going to do the job for this, so you don't have to worry about this. But all you have to worry about is actually you're going to use Node, because the whole project in here is actually based on Node. The whole project is going to run on Node, the whole script and everything. So since all of this is actually JavaScript, so I'm going to extend Node, and I'm going to add like our kind of dependencies and how to install dependencies and everything, and I'm going to start up the projects as we expected. All right, so I'm going to do from, and you give it like the image name. So there's actually, it's going to give me a list of images that are already available on the hub there, or the registry. I'm going to use Node version 14. And I'm going to do an as this one, or this as keyword. What it does is just like you give it like a nickname of what this image is going to be doing. For example, I'm going to give it like this as a production. So I'm going to use this Node 14 as a production for this particular Docker file. Pretty sweet. Now the second thing in here, I'm going to use another command, which is called the workdir command. And the workdir command in here is pretty much tells it like to change the currently working directory to another directory. And remember, always, a Docker container or a Docker image is just basically a Linux or a Unix kind of like operating system, small operating system running on behalf of our operating system. So that's it. So any kind of like Linux command, of course, Linux basic or Unix kind of compatible command can run in this particular sense. So basically you can imagine this as a cd Unix command, just like to change the directory. So what I want is actually to go inside like, for example, let's say I'm going to use inside of like a user src, I'm going to go inside of like API. So the whole code or the whole kind of like application core is going to be residing inside of this like this folder. And if it doesn't exist, it's going to create it for us and everything. So it's going to handle everything behind the scenes. So I want to have something else, which is an environment variable. So I'm going to put this env in here, which is going to set an environment variable inside of our container with a specific value that's going to be used. It can be used by anything pretty much. For example, it's going to be used by our application or something that's going to be running alongside our application. So just like an env variable is going to be applied throughout the whole Docker container in that particular sense. So for example, I'm going to put in node env, which is going to tell our application that, oh, we're going to run this application on a particular or on a production base throughout the node env environment variable. So I'm going to put like production, and this is going to set it throughout the whole container. All right, pretty sweet. Now the second one, most basic one, I'm going to be copying the package.json. So I'm going to copy package.json two dots, or basically, so the package.json is going to be copied from this local directory, which is right over here. It's going to be copied to the targets, which is right over here inside of the container. So this is what the copy command does. And we're going to also copy the package, so package block.json inside of the container as well. So just like to be able to do that. So after copying all of this, let's go ahead and do npm run and install. And just like to install the dependencies in a production based environment with that. So it's going to install all the dependencies on the package.json. So after make sure the dependencies are installed and everything, and what we're going to be doing is actually do another copy, which copies everything from this, like everything from this local directory, which is inside of the API, like where the Docker file resides. So everything is going to be copied inside of the Docker container. So this is what this means. Like dots means the local directory, and the other dots means the local directory in relative to the Docker container running. So that's basically what it is. And the other thing in here we're going to be using actually another run npm install, or pretty much npm run build, and this is of course going to run the build after installing dependencies, after having the whole source code put in there, the whole projects in here. I'm going to run the build command, which is going to build for us, or just like create this build folder, and it's going to create a fully sophisticated production ready build for us to be able to use this. So yeah, hope you're all guys familiar with all of that, with Node.js and everything, because this might seem a little bit kind of weird if you've heard it for the first time. So make sure to get some knowledge or grasp some knowledge before jumping into the video. So this is going to run the build command. Now the last thing on this, like on last thing on a Docker file, you have to provide like an entry command that after running all of this, this is pretty much just like a preparation is going to be done behind the scenes just to prepare for the startup of the actual container. This is going to be run by this image in here. So the CMD in here is going to be like the main command executed by default by the entry or by like when starting the container. So this is like going to be the running command that is the main running command on the actual container. So you can imagine this like running or starting up your server or something like this. So this is basically what we're going to be doing in here. So the command takes first like a couple of arguments. I'm going to use the ch or the shell kind of like command to run this. So make sure to use this because this is actually a really safe way to do it. It really perfect to do it and run it on a shell environment just to make sure that it's running perfectly as you want it to be. So that's why I'm putting shell and I'm providing C just to run an embedded custom command. And here what I want to run is actually run start production. And this one is going to run us the production script. So take a look on the package.json. It's clear to see there's a start production and it's going to run Node.js with a build from the build folder in here, and everything's going to be running as expected to be. Alright, so that should be it for this Docker file. And yeah, so the Docker file now should be ready. It's just like that simple. We set some env variables, we change the work directory, copy the needed files for installing dependencies, and basically just copying the rest of the source code. And last but not least, we just like build everything from the source code and the dependencies and the installed modules and everything, just like combine them all together. And last but not least, we run or start up our server, and that's basically what it is. So pretty simple, right? So this is the image. Once it's built, you're gonna have all these instructions, like, you know, however in there, gonna be like just like crave there. And whenever we start the container, this instruction is gonna be starting one by one, just like doing all of this sort of stuff. And this command is going to be started once we start our container in production. All right, pretty sweet. Now that's what we should do as well for the second one, which is the client. So that's why I'm copy pasting in here. I'm going to have another Docker file, and this one I'm going to just like copy pasting, just change a couple of stuff. Now instead of like, for example, instead of like API, I want to go, for example, let's say clients. Of course, this is not mandatory. You can completely ignore this, but I'm just like making sure that I set where the working directory I'm working on, because later on for debugging or stuff like this, that would be really, really useful for you guys. Just like go ahead. Oh, I know that I'm putting my code inside of this like user SRC client directory. So yeah, why wondering? So just like access the shell of the Docker container or running the Docker container, and you can directly go into this directory and find some logs or debug something inside of there just to know what is exactly happening. And of course, copy back package.json, npm install, run the build, and run the production. Pretty sweet. So that's basically identical, both of Docker files, on how they should look like and how they should run. All right. Pretty sweet. Now to build these images, all we have to go ahead and run is actually the Docker build. Now, for example, go ahead and cd into the actual client. So I'm going to do cd client, and I'm going to do Docker build, and you give it like where the directory that build resides in. Of course, it is inside of that directory. It's going to run all these commands. It's going to run from node, so it's going to grab this node. And if it doesn't exist inside of your machine, so what it does is going to go ahead and pull it from the Docker registry or the Docker hub. It brings it first, then it starts building. But for me, it's already there. I already used that. So yeah, that's all good. As Chris in here is installing the dependencies after copying back to JSON and everything. And it starts, you know, doing some regular npm install stuff, going on behind the scenes and everything. So now it's copying the whole source code. So it's copying basically everything right here into the actual container, and that should build the whole image for us. So just like wait a couple of seconds. Of course, the build might take a second to a minute depending on how much big the project is and everything. So yeah, that should be all good. As Clusin here did the whole build after installing dependency, so he did a full Webpack build for building the all assets into a production ready kind of distribution folder. And yeah, so the building is actually successfully done for building the image. Now to check out the image, what we can do is actually Docker images, and it's giving us the list. So just take a look on the most recent one, and there you go. So this is the number of seconds that we created, and you see none in here because we don't have, we didn't send any kind of like tag or a name for this image. We just said, oh, Docker, you got this Docker file, go ahead and build me this. And we didn't actually specify anything. But what we can do is actually go in and do like Docker build. And if you want to check, for example, what kind of like flags are there, so just like do Docker build -help. This is actually going to give you everything for this build command and what you can tweak. And for example, you can take a look in here. Where is that? So you can clearly set a tag, which you're going to name it for an optional tag in here, that what you want for your particular image, or you can give it like a name or like what the name is. So you can use that -n or an name just to name this and how you want the image to be, or the build image to be eventually, and how does it look like. All right. So that should be all good for this Docker build and how it builds the image, and it puts it inside of like your own kind of memory. Of course, you can take this image after like building and everything, you can go ahead and push it into your own custom repository on Docker Registry Hub, or on your own private repository, why not, or on Amazon ACS or something like this. You can have it actually pushed out there, and you can reuse it whenever you need. Just put it out and you can run it on your servers or whatever. So this is basically how distribution works. Of course, it's a little bit more complicated with pipelines, CI/CD, and all that sort of like DevOps things. But yes, this is basically how Docker is being deployed and how it works with this kind of built images behind the scenes. Alright, pretty sweet. So we got the build and how to build this from a single, simple Docker files. But what we want, actually we don't want to do it this way, because this is actually kind of like a horrible way to go. Go ahead and build this particular folder or particular Docker file, like the client one, then go to the API, build it alone, then just like have all the builds, then go back into like running each container by itself, putting bunch of commands that you probably can actually forget about, and all of this sort of stuff that doesn't really make it that good to just use Docker for deployments in these big projects. So imagine, for example, for this particular case, we got the client with an API, and the API basically needs behind the scenes a Postgres server running on the local machine or on the local host in order to be able to connect and start up the API. Otherwise, the API will fail and it won't be able to connect to that particular database. So it needs actually a Postgres kind of database already started. It doesn't matter if it's Docker or not, but of course, Docker is preferred because everything is in Docker. So make sure to have the whole stack in Docker. And this is where Docker Compose comes into the play. So what Docker Compose is pretty much like relies on a Docker engine. So it just like allows you to have all of your Docker kind of builds and all your Docker files, like literally these Docker containers, for example, for the clients and API and a Postgres, which are called services. So have all of these services combined together into a single, simple, minified, and really well structured file with the whole kind of configuration, the whole kind of commands to run, images, tags. You can have them like with volumes and different networks set up, everything inside of like a simple, easy, and custom YAML file with the whole configuration of all these services. So that's basically what Docker Compose is, just like a CLI that allows you to manage and read this kind of like YAML file and pretty much run these services alongside the Docker engine. Of course, just gonna like read the YAML file and just like provide everything to the Docker engine in a really nice and smooth way. So first things first, Docker Compose is not installed with the Docker engine, just to be sure and to be clear. For Windows and Mac, yes it is, throughout the whole desktop installation kind of tool set. So as soon as you just like install it once, you get it everywhere. So Windows and Macs, you're good to go. If you're Linux like me, well, you're still not. So you've got to just go ahead and install this again. Of course, you can go and install this throughout different ways, but the most perfect way is actually to go in and follow up the documentation. So let me just bring you the documentation real quick in here on how to install it. So I chose Linux in here for installing Docker Compose, and this is basically what you need. So go ahead and like run the sudo script, which is just basically a simple script that allows you to basically have the Docker Compose CLI running throughout your shell just to install a couple of stuff. So you can go ahead and run this one, which I already did, of course. And then you can go in and change use the change mode which is like changing the permissions for the Docker Compose that is already put inside of like user local bin Docker Compose. So just put it there. And last but not least, you can go ahead and like do sudo Docker Compose in here just to complete the installation of everything. Then yeah, that's it. Just to make sure that Docker Compose is installed after running all these commands, all you have to do is go and do like -v. It's going to give you, Docker Compose version 1.29, whatever. And there you go. So you make sure that Docker Compose is actually running inside of your machine. Okay, hallelujah, we got Docker Compose. Now let's go ahead and start composing our application throughout Docker Compose. So what I want is actually to have another file inside of the root folder, because this file is going to be the Docker Compose, is going to be linking both the client and the API in a single place, plus the Postgres server as well. So I'm going to have this like called Docker Compose, and this is pretty much the kind of like, standard way to pretty much name it. So make sure to like use a standard name in here, because that's really well in compliance with developers and all that sort of stuff. So this is pretty much for the YAML and how it looks like. Now, if you're not familiar with the YAI or the YML kind of like syntax and how it works, it's just like basically if you're familiar with JavaScript on how kind of like key value pairs works, that's basically what it is. Just like I give it a key, then I give it a value, and that's it. Now, to start off, we're gonna have to first define a version and what type of like Docker Compose version we're gonna be using. The last version, as far as I know, is either 3.8 or 3.9. So I'm gonna use 3.8 respectively in here because it works really well. And the second directory I'm gonna call is gonna be the services, which is the most important one. Now, services in here are actually each service, or pretty much represent each kind of container you're going to be running. So for example, the client is actually a service, the API is a service, and the Postgres server is a service. So I'm going to put in all of these servers behind in here with a different configuration from one service to another. So first things first, I'm going to name this Postgres. You can give it whatever name, however you want. So this is going to be the Postgres server. Now here, we're going to give it the image, the image name I'm going to be using for this particular service. Like what image name I'm going to use it to run this Postgres service. So the image name, I'm going to use Postgres, and I'm going to use 11.5. So the same way we did it before when we did like Docker run and everything. So this is basically the same way how it should look like. So the second one, I'm going to use the restarts. And the restart in here tells it like when to restart this container. So what kind of condition happens to restart the container. I'm going to do always. So anything happens, any crash, anything happens to the containers is going to pretty much allow it to always restart the Postgres, because this is a very important. We want always to make sure Postgres is actually up and running whatever happens. All right. Pretty sweet. Now got another one, which is called environment. Now environment here, you give it like what environment variables you have. And as we've seen before, Postgres in here has a couple of environment variables to make it work perfectly. For example, the Postgres password, which sets the actual Postgres database password for you. So that's why you want to pass in here. So for example, I'm going to put Postgres password, and you give it like what type of password you want. As clearly I'm using this like dash in here, which just basically annotates and tells that we're going to use an array kind of type in here, because there's different types on this YAML format. If you're not familiar with that, but that's basically what it is. So for example, give it a password like 123, and I want to use another environment variable, which is like the Postgres DB, which basically tells it what is the database name I want to create by default once I start up this particular service. So I want to, for example, create a database called Jira Development, which is going to be used for our, of course, our API kind of client in there to connect to. All right, pretty sweet. You got the environment variable, and this is what's going to be created and set it up for us on the Postgres kind of image. So, and if you're actually saying, oh, how do you know this? Like, this is the environment variables, and how do you know all that sort of stuff? Well, this is all about like the Postgres image, and of course it depends on every single image on how it works. So make sure to check out the documentation, or pretty much the docs or the description of the image on the Docker Hub or whatever other image before jumping through, just to give you all the details on how that works. All right. The other part we want to do is actually the ports, and this is pretty much we're exposing ports. So as we did it before, where we expose ports, like expose internal ports to the export, like external ports. So this is the part where we do it in here. And I'm going to export basically three, or the same port pretty much from outside, or pretty much from inside, which is this one represents inside of the container, to outside the container to our host machine for this one. You can, of course, choose a custom ones, but that doesn't really matter for that particular part. All right. We can use networks. Now, for example, for networks in this particular part, what we can do, like if you're familiar with Docker and how it works, it pretty much, there's this by default a shared network between all the services or all the containers running on the host. But of course, you can create custom networks. In our case, what I want is actually create a custom network, but still, I'm going to use the same network for all the containers or for all the services to connect to and communicate through, and to be the whole containers running on the same network to be recognizable, if that makes sense. So I'm going to name this my network. I'm going to name it shared network. I'm going to create the network in a sec. So to create a network, just put in another network directive in here, which is the same level, like on the root level or the same level of the services. Just don't be mistaken, and put in like a shared network, the same name. And this is, you make sure you put a colon in there, because this is the creation, like you decide like, oh, this is the objects of it. All right, pretty sweet. Now we've got the network and everything. Now, last but not least, and this is only specific to this Postgres. If you're asking why, now we need a volumes. Now volumes in HQLC, like the volumes to be created as part of your application. So the volumes, what it does, it basically actually exposes data inside of the container and binds it or links it to another kind of like directory or a file outside of the container, which what I mean by outside is actually on the host container, on the Linux machine in here, and this for this data to be actually persistent. That's basically why this data should be looking like this way. So I want to make sure it's persistent, and for databases, this is a very important step, because it's going to allow it to expose data, because if you lose the container, for example, if you remove the container or the container is stopped, you're going to lose data, and you don't want to use your database data. This should be really bad. So make sure to use volumes to actually bind data inside of the container, which gonna represents the actual database data, and bind it or link it outside of the container, so the data to be written in outside of the container, and to make it persistent to live outside of the container and inside of your server, if that makes sense. So just the volumes in here, what it takes a directory where I want to put it. For example, when I put it, for example, Postgres DB, so I'm going to create this folder, and I'm going to link it to the data file or the data directory where data exists for the Postgres inside of the Postgres container. All right, so it exists inside of var lib and Postgres SQL or PostgreSQL, whatever you want to call it, and /data. So this is the folder or directory where data is going to be put from the Postgres database. I'm just going to link it to this directory, which is going to be created for us right here on the loop level automatically by Docker, so we don't have to do any other further steps. Sweet. Now we got this Postgres service already done for us in a really awesome way. Like it. Okay. I'm going to copy this one. I'm going to create the rest of the services. Now, the second one, I'm going to make sure, like always, to match the levels. Otherwise, it's going to like yell at you with random errors, and you don't want to do that. No one loves yelling. Okay? So, the second one in here, what I want is actually to run the actual API. And for the API, we're not going to use an image. So I can completely get rid of this, because we're going to use the Docker file to build everything. Because we got the Docker file in here. We're going to use this Docker file, tell it, oh, there's this Docker file, and take me this Docker file and build me everything I want it to be. So I'm going to use this. I'm going to tell, for example, oh, let's go and change the name first. I'm going to name this API. I'm going to give it container name. Like, what is the container name? I'm going to be naming this after running it. Let's say I'm going to name this, for example, the Jira API, just to be agnostic and kind of like simple. For the restarts, I'm going to do endless stops. So only restart this once it is stopped, just to make sure that we always keep it up to date and always keep it running. For the image name I'm going to be creating, I'm going to name something like Jira-API-prod 1.0.0, just like for some simple versioning. All right. The second one, I'm gonna have a build. I don't need this actually, so I'm gonna get rid of this. Now for the build in here, it tells it how we're gonna build, like tells it what is the Docker file or which Docker file we're gonna be using and the context and everything. I'm gonna provide the context, which is basically represents what directory you're gonna be using. So for the directory, I wanna go into the API. So I wanna use this API directory. For the Docker file, I wanna use the Docker file inside of it, which is named Docker file with a capital D. It's capital D. And for example, when I put as well a target, like what is the target version I want to target in here, I'm going to target the production. All right. So that's simply is going to tell it to build, to go into the side of the API folder and pick up this Docker file and build it for us. It's going to build this API image for us in a really simple, easy peasy way. Sweet. Now the ports in here, I want to export this port, and for our server, for our application, like the API in here, is by default configured to listen on port 3000 internally. So the container is going to have 3000, and I want to bind this 3000 to outside of the container, which is going to be exported into our host in here as 3000. So that's what I'm doing in here, and just like exporting this to be able to run all over the place there. And for other containers to listen to, otherwise it won't work perfectly. For networks, it's going to be same shared networks, and volumes, we don't need any volumes. That's it. We just don't need any kind of volumes. But what we need is actually another kind of attributes, and this one, it depends on. So here we give it like a list of kind of like services of what this particular service depends on. Like this API service has or needs Postgres service or Postgres database to start up first before this API should start. Otherwise, this API should just like wait for this. Once this is started, this API should start. So this is pretty much the logic. So for the depends on in here, I want to tell it, oh, this one should depend on the Postgres service, and that's it. So that's basically what we need for the API in this particular sense. Now this is for the second service. Now the third service, is going to be the client. So I'm just going to try to be quick in this and copy paste this. So just Jira API, going to be Jira client, and here going to be a client. For the start, it's going to be the same thing. Here we're going to have a client as well. The context is going to be inside of the clients folder. Remember, we're going to have it right there. Production and Docker file the same. For the ports, this one is going to be exporting. Our internally is going to be running inside of like 8081. And I'm gonna just like go ahead and export this to 8080 or something, just for the sake of simplicity. All right, shared network is gonna be the same, but this one depends on the API for this to work. So it waits for the API. So they're pretty much like a chain, since the API waits for the Postgres to run, and the clients waits for the API to run. So it's kind of like a waiting chain, each one waiting for the other, and that's basically what it is. Alright, we got a pretty well made up configuration, our Docker Compose, and it's pretty simple. Now, this Docker Compose, or this whole kind of services stack in here, what's going to happen is actually going to have a single Docker Compose command. We're going to run it on the root in here, and what's going to happen, the Docker Compose is going to take the file, read it, and you know, oh, there's three services. So if there's like kind of like services, or if these containers are not already built, which means they doesn't exist as images inside of like system, it's going to try to build them from scratch. And after that, it's going to try to go ahead and up those or like start them. And it's going to start them, of course, depending on the pretty much the criteria you provided in here, the ports, the environments variables, the Docker files, or what image you're going to use already, or all that sort of stuff. So it's going to start Postgres, it's going to start API, and it's going to start client, all at the same time with a single command, and that's it. That's all you have to worry about. And Docker Compose, even it has like this kind of daemon mode where you have to run it once and never just think about it before, because servers, of course, you've got to run those on a daemon, and once the server is restarted or something like this, Docker Compose is going to take care of this behind the scenes for you. So simply, all you have to do, just go ahead and run the Docker Compose command, and Docker Compose is going to take all of the rest depending on the Docker Compose YAML file you provided in here with all of these configuration. How sweet is that? Pretty awesome, and that's what I like about this. Alright, so let's go ahead and run all of this. And first things first, we're going to use the Docker Compose. Make sure you are on the root, which I'm not. So we need to go ahead and back into the root in here where the Docker Compose actually exists and run Docker Compose build. And this should go ahead and build us everything from scratch. So we start from, if you take a look, where is that? So it's going to build in API, and Postgres uses an image already built. So this is why it's keeping it. And just like going ahead and building all of that. And of course, this is going to take a couple of minutes because it's going to build a couple of images and it's going to install dependencies and all that sort of stuff. So you have to bear in this and wait a couple of minutes to finish up, of course. And there you go. So that is well made up. Actually took a couple of seconds to a minute to build up everything. So now we got the images built up. Of course, you can go ahead and do like Docker images to check out the images built up. Take a look on it. Those are actually our images built up like 20 or 48 seconds or whatever. This one has built 24 minutes. I think this is a cached version when I tried it before, but whatever. So Jira API production, Jira client production, version tags, image IDs, and all sort of stuff. Of course, the size is tremendous because we got extended the Node.js kind of like image and having our custom stuff going on. Now we got everything built up. Now the second one we need to do is go ahead and do like Docker Compose -up. And this is the best command in the world. And all it's going to do for us is going to take care of everything from here. It's going to run all the actual services together. So you see all the services are going to print out all the logs from different services in different colors, which makes it really, really awesome and really well readable. Now the application started, the API started, and the client started as well. Plus, the Postgres now is actually accepting connections. So everything, literally everything is actually connected together with a single command, with a single file, and everything is actually Dockerized with Docker files and everything. How sweet is that? Now, if we go ahead and take a look onto this, remember, we already exported those kind of like, if we go to the 3000 where the server lives, there you go. We got this cannot get because the server is kind of like runs on different routes. And if you take a look on 8080 where we got our client running, take a look on this and it's spinning. Hope that doesn't take forever. There you go. We got the whole application in here. It's kind of Jira clone and it does look really well made up as a Jira clone. And yeah, I kind of love this. And seriously, it runs from this 8080 ports running on a Docker container. On top of this, everything is running. And indeed, the Postgres is running, is accepting connections, and this Postgres is actually connected to the actual client pretty much, or the API in this real way. Now, one thing I actually didn't mention, which is kind of tremendous, and you might find a little bit of issues if you're not familiar with much of Docker Compose on that particular part, of how to link this together, of how to link like the API together with pretty much like the Postgres, like in terms of hosts, because right now they all run in terms of Dockers and the same network, and they don't know like what local host is or something like this. So how to link this one, what you need to go ahead, it's actually like, for example, like the env, scrutiny for the env file, like where the configuration live. So you can have this anywhere in your code, like where you pretty much do database setup or something like this. So for the password, I'm passing in my password in here, like the database name and the username and everything for Postgres. And the other part in here is exclusive to DB host. I'm using this Postgres. And this one represents the same name of the service because that's how Docker internally actually resolves host names by just like their service names or Docker Compose. So that's basically how you point it that way. If you want to like point it to the, like from the API, tell it I want to access the Postgres SQL database server, we just like pointing to the service name in here, just like provide the service name. So whatever you change in here, change it there, of course, and that's it. So just like point it that way. If you want to point the client to the API, like you want to have like RESTful API, of course, connected to the API and do connections. So all you have to point it to is actually this API service. So instead of doing like localhost, then whatever routes you got, you do like API, then / whatever stuff like this. And Docker is going to do the job perfectly for you, or Docker Compose is going to like handle this behind the scenes. It's going to resolve the right address for you. It's going to like bind it and everything. So all you have to worry about, just provide the right service name for your like container to be able to communicate to each other's internally. Otherwise, it won't work for you. So yeah, that's pretty much it for this, guys. I hope you guys enjoyed this video tutorial. I tried to make this as simple as possible, as quick as possible. I tried to provide everything as you need to actually take a Docker from start to finish on how Dockerization works, on how Dockerizing a real world projects from start to finish throughout React, Node.js, with PostgreSQL, and with a whole kind of stack of servers. Plus, we also use some Docker Compose to put all of these services in a single file and have them running up with a single command. So hope you guys all enjoyed this one. I've enjoyed making every single piece of this video, and hope you all guys actually liked it. Without further ado, hope you guys enjoyed the step before, and catch you hopefully in the next ones.